All right, section 1.2, we're going to talk more about limits. All right, so all of chapter 1, by the way, is limits. It's about limits in chapter 1. So 1.2 is finding limits specifically in two different ways. One of them is graphically, and one of them is numerically. Now, the exercise that we did at the last problem, where you were doing all those calculations over and over again with slope in your calculator, that's a numerical process. So if you want to write down real quick that when something says graphical, it means graph. And when something says numerical, it's talking about tables in your calculator. That's actually true. So anything you see that's graphical means you've got a graph or you're looking at a graph. And then the other one, numerical, will be looking at tables. So to start with, the limit. So a limit is a y value that you approach, but you may or may not touch. That's what a limit is. It's a y value you get close to. There's some notation that we're going to be using, and we need to use it all the same way, right? You're using it the same way that I'm using it, the same way your textbook's using it. So these are the three different notations that we're going to start with. So you'll notice the sort of the phrase LIM for limit. It tells you what you're taking the limit of next. So this one's saying the function f of x. It could actually have the formula for the f of x in there too. That would be fine. Underneath, it tells you what x value you're getting close to. So like that last example that we just did, we were getting close to an x value of 2, right? The tangent line was supposed to be at 2. So that would have been, it would have said x equals, or x is approaching 2. The positive sign, or the negative sign after it, tells you which direction you're coming from. So if it says positive, you're coming from the positive side. That's the right-hand side and getting close to 3. Okay, so you're moving left, but you're coming from positive. And then if it has a negative, you're starting on the negative side and you're getting close to the x value of 3. And if it doesn't have anything after it, it means you have to come from both directions and arrive there. So we're either coming from the right, from the left, or from both sides. So we will actually say that a limit exists, or there is an existence of a limit. The limit exists if and only if both coming from the left and coming from the right lead me to the same conclusion. So the corresponding one-sided limits are they both exist. We approach the same thing, or we approach something, and they are the same thing we approach. Okay? So this would be something like this. If you told somebody, I'm going to meet you at McDonald's for lunch, and you thought they meant the McDonald's on Harrison, but you meant the McDonald's on Kickapoo, and you both go to those locations, and you arrive there, right? You got infinitely close to the location, McDonald's, but you are not in the same spot. That's a problem, right? That can happen on a graph, right? You can both approach to something that's the same x value, in this case McDonald's, but not actually be at the same place at all. So what we're going to do on the next example is look at a graph and look at some different ideas of how that can happen. So this graph should match the one in your notes if you've printed it off. If not, sketch it on there real quick. And we have 5 different limits we're going to find. Now, each of those, they're not written in. Sometimes it's hard to get graphs to do what I want inside of PowerPoint and then put inside of PDFs. But these are all ones. So this is like -1, -2, -3, and so forth. So each of my hash marks are 1 unit apart, okay? So the first one says that when approaching x equals -1 from the right. So this is the location that I'm approaching, -1, but I have to do it from the right-hand side of the graph. So what you can imagine is that you are on the right-hand side of the graph. It doesn't really matter where you start, but you're moving along the pink arrows. And you're getting really close to that open circle that's on the graph, okay? So while I recognize that this is filled in, you cannot get there along the right-hand side of the graph, right? That's not where you're getting close to. You're getting close to the open circle. So what we would say that the limit is it would be the y value at this open circle. And what is the y value at that open circle?
2.
It's 2. So my limit, as I approach the number -1 from the right, is actually 2. It's that open circle. So we'll change colors. We'll use blue. The next one, part B, says I'm doing the same thing. I'm getting close to x equal -1. But I'm not going at it from the right-hand side anymore, right? I'm coming at it from the left-hand side. So the left-hand side is down here. I'm starting over here, and I'm going towards x equals 1 along the blue arrows this time. And when I arrive at x equal -1 or get infinitely close to x equal -1, what y value am I at now? I'm at 1. So this value has a limit of 1. And so you can imagine, if one person's going along the pink arrows and one person's going along the blue arrows, they do not arrive at the same location. They're at 2 different points in the plane. And so when that happens, what we actually say is that the limit does not exist. I abbreviate it D&E. It doesn't exist because they've arrived at different locations. So there are these places where we have jumps in the graph. There's these disconnects that happen, and when that happens, we don't have limits. Now, I throw in here D and E because what I want you to see is there's nothing special about, oh, I only find limits when there's these jumps in the graph. No, of course not. I find limits at other places too. Okay? So sometimes I'm finding limits at places where there's not any jumps in the graph. It's nice and it's smooth and it's well behaved is what it really is. So what I'm going to do is I'm going to erase all my markings because I've made a mess out of my graph so that we can identify a different x value. Part D wants the x value of -2, which would be here. Okay? Now, if you're coming at this, you have to come at it from both directions. Why?
Because it doesn't have a negative or a positive.
You're right. Exactly. There's nothing after this that says plus or minus, right? So when there's not a positive or a negative after, it means I have to come from both directions. Now, coming from the left-hand side feels very much like the last problem I did. I mean, I'm on this horizontal piece, right? And as I'm doing that, I'm getting close. It feels a little bit funnier to come from the other direction, but let me show you that it's still okay. We can still approach like this. We just jump down and we keep going. Okay, so that's okay. There's nothing wrong with the jumping down business because I haven't gotten to the x value or gotten close to the x value I want to be at. I'm still trying to get close to the x value of -2. So in this case, approaching the x value of -2 from both directions, I do arrive at the same location, don't I? I do. It's the x value of, of 1. So on this one, the two-sided limit actually does exist. And the reality is it's existing because there's no jump in the curve, right? Because it's nice, smooth, continuous. It's well behaved when I'm at the x value of -2. So we're going to do the last one, which is an x value of 0. So at an x value of 0, I'll write it in, but I'm here, right? So I'm at this location. Generally speaking, I'm in this area of my graph. And I can approach from the left and the right just like I did on the other one. So I'll approach from the right first since my pink's still on. So approaching from the right, I'm getting close right there. And if I approach from the left, I am on this horizontal piece for some period of time, and then I have to jump up because I haven't gotten to x equals 0 yet, right? So I can still make the jump. But as I'm getting infinitely close from both directions, it does approach the same place. It's hard to say exactly what that is, but we can tell what we think it approximately would be. What does it look like you might approximate that to be?
1.75? 2.2. That's what I'm doing.
Yeah, so maybe about 2.75. So I'll put an approximation just to remind us that we're guessing a little bit because my graph is not crossing at a nice whole value amount. But it exists. It's the same value. Whatever it is, it's the same value from both sides. Okay? So this is graphical limits, and it's all the points of graphical limits in this section. So it's actually a fabulous place that we got to stop. So we will pick up next time with numerical limits. And a reminder again, too, next time we will end class a little bit early, about 10 minutes early, because we have Convocation Chapel to get to, okay? Or at least I do, for sure. All right, so have a great day, and I will see you guys all on Wednesday. And remember, web assign for 1.1 is due on Wednesday before you get here. Okay?